Hello everybody, I'm going to take some time here to show you how to use the Desmos graphing calculator, which we will be using throughout this unit. It is an exceptional tool, so if you go to the math tools on Desmos and click graphing calculator, it'll open it up for you. Okay. You don't need to worry about saving any of your work. It's almost just like a numeric calculator where you can check your answers for graphs. So a couple little things to know. The cursor, you can kind of slide it around and, adjust where you have your graph. You can also zoom this in and out. So you can see that my unit boxes are now only counting by fives. The scale is counting by fives, but each box is by one. I can zoom in and take it all the way up to 1. I can also come over here to the settings and I can change my scale, but we're not going to do that quite yet. We're just going to practice with just using the zoom in and out. You can zoom in completely, zoom out completely, however you want to do it. I'm going to leave it as a 1-to-1 graph at the moment. So each one of these boxes is a decimal then. So that would be like 0.2, 0.4, 0.6, 0.8, and then 1. Okay, over here on the sidebar, this is how you enter the information for the graph. So let's say you have an equation. We always write our equations in y equals something x. So if it's a proportional relationship, let's say if I have, let's say, journals. I want to go to the store and buy journals, and they're $2 each. And I want to know how much it'll cost if I buy X number of journals. So I could write y will equal, and y would be my total cost, to x. Now you can see that as the scale goes up, this is representing how many journals. So if I buy one journal, I'm going to pay $2. Okay, and if you hover your mouse kind of over it very carefully, you can usually find it. See, there it is, one. There, it's kind of hard to do, but you can find the exact point. One journal to $2. Okay, and then if you buy 2 journals, you're going to pay $4, and if you buy 3 journals, we can scroll up and you can see we're going to buy 6. We're going to pay $6. The other way you can do this is to represent it in a table. So if you go to the plus sign and you click table, if I buy 1 journal, I'm going to pay $2. So if I replace the x with 1, 1 times 2 is 2. So that's going to be my total cost. If I buy 2 journals, 2 times 2 is 4. If I buy 3 journals, 3 times 2 is 6. And if I buy 10 journals, 2 times 10 is 20. Now you can see the points. And if you click on them, you can see the labels. Okay? So this is a great way. Let me scroll up so you can see that 10 and that 20. If I keep going way up, there it is. See, there's my 10 and my 20. And if I zoom out, I can see them all at once. See that? Okay? And if you click on the dots, it'll light up the points, the location. Now notice this graph starts at 0, 0. That's because there's nothing at the end of my equation. There's no plus or minus. It's just y equals 2x. For every journal I buy, I'm going to pay $2. And the y represents the total cost. The x represents the number of journals. So you can put your points in either way. Let's say you didn't have the equation. I'm going to delete this box. If I didn't have the equation, then I would just have a series of points here. 1, 2, 2, 4, 3, 6. And these are all connected by a straight line. To show that straight line, all you have to do is go over to the edit button, and then you can click on that blue, the little purple, you can change the color, and then see where it says lines, you can turn that on and it will connect it for you. Okay? It'll connect it and show the graph, which is kind of nice. And then you can add the equation, y equals 2x, when you're finished, which is kind of nice. So you can see that this equation goes on for infinity in both directions, although practicality, we're not buying negative journals, right? So technically our graph would stop at 0, 0. 0 journals, $0. Okay, now what if we wanted to add a y-intercept to this? So I'm going to delete these 2 boxes and start over, okay? And I'm going to zoom out a little bit so we can have 1-to-1 there. Zoom in a little bit more. There we go. Okay, if you don't like the minor grid lines, you can turn them off. If you go over to the setting button, I think there is a button here. Yeah, see it says minor grid lines. If that's too confusing for you and you don't like all those little boxes, you can turn them off as well. Okay, so let's try a y-intercept. So let's say we go to Hershey Park, right? And Hershey Park tickets are, and I'm going to use a small number. Actually, you know what? Let's not use Hershey Park because this wouldn't be realistic. Let's say the Carnival. The Carnival sells ride tickets for $2 each, but you have to pay to get into the Carnival. So you pay a one-time fee to get into the Carnival, let's say $10, and you have to buy tickets and they're $2 each. So that would be y equals $2 for each ticket plus the $10 to get into the park. Actually, let's say 5. Let's make it smaller number so we can see. All right, now notice how different this graph is. Notice that it crosses at the 5 and not at 0, 0. This is not proportional. Let me show you how it's different from the last example. So notice this one crosses at 0, 0 because there's no plus or minus. See that? The y-intercept is that extra that we're adding onto the equation. It's usually in the real world the startup cost, the initial fee, the deposit, things like that. Something you pay once and you're done. Whereas this is going to be more of a constant, something you're going to be doing every month, every day, every ride. Okay? So you can see that these two lines are very similar. They're parallel because they have the same slope, the same 2 times something. The difference here is that we added 5. So that is going to lift our line up on the x-axis or the y-axis, and that's where that line will cross instead of 0, 0. Okay? Again, you can create a table to represent this. I'm going to delete the y equals 2x because that was from the last graph. But we can create a table to represent any number of rides. How much will this cost? So I'm going to go to the plus sign. I'm going to create a table. Okay, let's say we only want to ride one ride. Actually, let's say 0 rides. Let's say you're going to the carnival with your friend, but you don't like rides. You are going to ride 0 rides. You still are going to have to pay the $5 to get into the carnival, whether you ride the rides or not. That's that plus 5. So see, this is what we call the y-intercept. This is where the line crosses the y-axis. And in a real world application, it's when 0x is 0. When you're not buying anything at all, you still have to pay that $5 to get into the carnival. All right, let's say we want to ride 2 rides. Okay, so we're going to ride 2 rides. So that would be 2 times 2. So that would be $4 for the tickets plus 5. So my total cost is going to be 9. Now I can scroll up and see that that point is on the graph. See that? So if I buy 2 carnival tickets, I'm going to pay $9 in total. All right, let's do one more. Let's say we want to ride 5 rides. So we're going to ride 5 rides, so x is 5. 2 times 5 is 10, but we still have to have that plus 5. We still had to get into the park, into the carnival. So if I ride 5 rides, I'm going to pay a total of $15. So let me zoom out a little so we can see it. Okay, so see, here's my 5. I rode 5 rides. Here's my total cost, 15. And again, you can click on the dots and see all of the points that we graphed. Pretty nice, right? So the graphing calculator is amazing. As we get into the unit later on in the unit, we will also be able to graph more than one equation. So I'm going to delete the table and we'll leave that one here. And just like the one we just did, y equals 2x, now we can compare 2 lines. You can see that this one has a y-intercept of 0, 5 because of that plus 5 at the end. This one has a y-intercept of 0, 0. We call that a proportional relationship. Proportional relationships at any time it starts at 0. This is also a relationship, but we call it linear because it doesn't start at 0, 0. However, it creates that straight line. These 2 lines are parallel because they have the same slope. Now, what's really cool is, let's say we want to change this to a negative slope, okay? Negative 2x. Check that out. The line is actually going down, and you can see that there is a point where these 2 lines intersect. The point of intersection is where both of those lines have the same value, the same answer, which only happens once in the whole entirety of the line. So you can see the blue line is going in the opposite direction, the green line is going in the opposite direction. They meet once in life, and that's it. And they meet at negative 1.25, comma 2.5. So my x-axis is negative 1 1 1/4, and my y is 2.5. Okay, and we'll get into this later as we move into the unit. You can graph as many lines as you want on one of these graphs. We can even do, let's do y equals, let's see, y equals x. See, that one is a 1x, so we could put 1 here. Let's do x equals 5. I like x equals 5. X equals 5, it runs up and down like vertical. Okay, x equals 5. You can see how there's no y, so it just goes straight up and down. And y equals, let's say y equals 2. Just going to make up 1. So that is when the line goes across, left to right. Notice there's no other component to the graph. No other component. And what's really cool is you can move this over. Isn't that cool? I love this. So you can see what happens when you change the x value. Same with this. We can change the y value by taking it up and down. Pretty cool stuff. Then you delete, just click the X button to delete, and you can take it right back to where you started. Have fun playing with the graphing calculator. I'll post the link in our Desmos. It will also be found in our Schoology folder.